So this lesson that we're going to do is all about how to prove that two triangles are congruent. We've talked about how to compare two triangles that we've been told are congruent, and we've discussed how to prove that two triangles are similar, but we haven't talked about how to prove that two triangles are congruent. So this video is all about different postulates that we're allowed to use to say, given this information that I know, these triangles have to be congruent. So here's the first postulate that we're going to talk about. It's the side, side, side postulate. So this means to me that all three sides of my triangle on the first triangle that I've been given are corresponding and congruent to all three sides on the other triangle that I've been given. So think of this as my pre-image and this as my image. If everything corresponds to what it says it's supposed to correspond to on the other triangle, then I'm good to go. So here, if you notice, I can drag this over. Single tick marks match up with single tick marks, doubles and triples. And when we're actually writing this out, like on a test or a quiz, or any type of proof that we do or examples, we'll just write SSS, or whatever the abbreviation is for the postulate. So you don't have to write side, side, side every single time. The next postulate that we're going to look at is the side angle side postulate. The most important piece of information I can give you is to make sure that when you're looking at your triangle, you travel in order of how things are attached to each other or related to each other. And I'll show you what I mean in just a second. So this one, it's two sides and the included angle. So I have to make sure that just like this says, the angle is sandwiched in between the sides. So if you look here, I'm going to start with this side. So I'm just so that we know what's going on, until we get really comfortable with this, I'm going to label this as side. I can't travel up to this vertex point because it's not labeled as anything. So I'm going to go from this side and travel to this because this is labeled as an angle, and we know that that means it's a right angle. So since this is connected to that side, and it's also connected to this side, I'm going to travel this way. So I have a side angle side on this first triangle. I'm going to think of this as my pre-image. And then if I look at this second triangle, I can correspond this single tick mark with that single tick mark. I can't travel down here because there's nothing labeled on this angle of my triangle, so I'm going to go up, which would be an angle, and I know that these are congruent because they're both right angles, and then finally a side. So in this case, that's how I would label the pre-image triangle and the image triangle to know that these two are congruent. The next postulate that I've got angle, side, angle. So now instead of the angle being sandwiched, the side is being sandwiched. And what that looks like on my picture, I've got a single tick mark angle, a side. Since I can't travel up this way, there's nothing labeled up here on my triangle, I've got to go to this side, and then finally to this angle. So I've got angle, side, angle. And if you notice, I can drag this guy over here. Everybody lines up together and corresponds to each other. So this would be angle, side, angle, and this would be angle, side, angle. Next one that we're going to look at is angle, angle, side. So now I have two angles, and then the very last piece is a side. Sometimes this one is a little bit harder to see because the angles aren't connected to each other. So I'm going to start with this single tick mark angle out here. The next thing I have to be able to mark in order to follow this postulate is another angle. If I travel up this way, there is no angle listed here, so I can't come to this part of my triangle. I have to travel this way to this double tick mark angle that's labeled. And I'm going to continue in that same direction, and there's finally my side. Now I should be able to do the same thing on my other triangle over here that I'm considering my image triangle. So if I start at my single tick mark angle, The next thing I would have to be able to label is another angle. I can't come down here. There's no angle labeled here, so I have to travel up this way of my triangle. And there's another double tick mark angle. So far I'm totally on point with that one. And last but not least, if I continue traveling in that same direction, I've got a side. So this is an example of what angle, angle, side would look like with a pre-image and an image triangle corresponding to each other. The next one I'm allowed to use is hypotenuse leg. This only works for a right triangle. I cannot stress that enough. Only works for a right triangle. That's it. So this is my right angle on both of my triangles. This corresponds to the Pythagorean theorem. Because I have a squared plus b squared equals c squared, if these are both my values of A and these are both my values of B, the only way that these two triangles could be congruent is if B has to be the same because of the Pythagorean theorem that works on my right triangles. So I'm only allowed to use hypotenuse leg on right triangles, and I would just write HL. Now there's a couple that we're not allowed to use in geometry. First and foremost, I am not allowed to use angle, angle, angle. As we talked about in our similarity and congruence video, angle, angle, angle is a similarity postulate, not a congruence postulate. This is not enough information to ever say that something is congruent. And I'm going to give you an example of why in a slide or two. I'm also not allowed to use angle, side, side. Angle, side, side does not work. And I'm going to show you an example of why it doesn't work. So keep these two in mind. You're not allowed to say bad words in my class, so you can't say angle, side, side. And you're not allowed to call for help. There's no broken down cars in this room. So don't try to use these two. They do not work. And here's an example as to why. Angle, side, side. I've got an angle that's both 40 degrees, a side that's both 8, and a side that's both 5 units. But I don't know about you, but there's nowhere I can go in this world and say that those two triangles are congruent. So angle, side, side, because I can show you this one example of why angle, side, side doesn't work, we can never use angle, side, side. Example of angle, angle, angle. All three angles correspond to all three angles on this triangle, but these are similar triangles, not congruent. So do not use angle, angle, angle as a congruence postulate, only similarity. And the very last thing that I'm going to tell you you're allowed to use, I can use my vertical angle knowledge and know that my vertical angles are congruent in order to prove that triangles are similar. So let's see what this one would be. So I'm going to start here. I've got a side that's marked. Can't travel up here. There's nothing attached. But I can travel to this angle. And because I know vertical angles are congruent, I'm allowed to use that as an angle. Everything on this triangle corresponds to its counterpart on this triangle. So this congruence theorem or congruence postulate that I would use is angle, angle, side. So I can say, because of the angle, angle, side postulate, these two triangles would be congruent. So I am allowed to use vertical angles. They are absolutely 100% fair game when I'm talking about proving triangles congruent. So those are all of the postulates that we're allowed to use. Make sure you bring these to class with you tomorrow, and we are going to start applying these and figuring out how to see all of these theorems and postulates in practice.